What? Leah's got no friends? No one likes her? How sad is that? All right, here we go. We have no actual math, gentlemen. Nice. I am taping, girls, guys, hold on. No actual math today, just some vocab. It's so easy. Welcome back to a day with no math. We love a day with no math. Are we ready? Sorry? Thank you. Are you doing the quiet coyote? Thank you. Thank you for quiet coyote. So today we have like 5 words to learn, and they're super easy. We used to, when we first did algebra, we only had U-graphs. So we had vertices, and that was it. But now we have more complicated graphs with more fancy points on them. And the fancy points we're going to call today critical points. So today, all your homework is going to be is I'm going to say, put this graph on Desmos and label the critical points and tell what they are. That's all it is. So it is no math. It is just a little bit of vocabulary. So we're watching. Everyone's with me. Yeah, okay. So here's what. Critical points are when the graph does one of 2 things. And you're going to write this down on your notes. It either changes its shape or it changes its direction. And here's what I mean by that. If I am a roller coaster and I'm going up, when you get to the very tippy top of your roller coaster and start heading down, that's a critical point. That's the best part of the ride, when you change directions, right? And that's one of our things. Extrema are where you change direction. And on a roller coaster, they're the best part, right? So if you're going down here on the roller coaster, woo, you love that part, right? That's where you change direction. And that's called extrema, right? Sometimes, though, your roller coaster just takes a rest. Like it gets to a point, and if you've been to like the Big Dipper in Santa Cruz, you get to that point where it just kind of flattens out for a minute, and then it keeps on going. Where it flattens out for a minute, that is called a point of inflection. And what that is really doing is it's changing its shape. And really what I think of it as either a rest, or sometime next chapter, I will call that a wiggle. Your graph wiggles for a minute. It just kind of sits here. It sits here, it wiggles, and then it goes on down. So if your graph takes a rest somewhere, just rests for a minute, that is called an inflection point, right? So we have extrema and we have points of inflection. We're going to talk about extrema a little bit more though. Come on, really, let me get through. Thank you. So here we go. Extrema have 2 types. There are maximum and minimum, and there are relative and absolute. So we're going to talk about first, these are called maximums. So here's what I want you to think about. You have decided that you want to become a mountain climber. You go to Mount Diablo and you hike to the top of it. Yay for you! Is it that impressive? No, because it's 5,600 feet. It's not nothing, but it's not that impressive. And when it's kind of like it's the highest mountain around here in the Bay Area, it's pretty high, but it's not that impressive. But if it's the highest in an area, that word is called a relative maximum. That is the highest in an area. But if you were like one of the poor people a week and a half ago who had climbed Mount Everest and a snowstorm came in and stranded 200 people on Mount Everest, well, you, 1, is sad because I think you might have died, but 2, climbing Mount Everest makes you super impressive. That bad boy is like 28,000 feet. It is called an absolute maximum because it is the highest spot on Earth. So in this graph, this guy is called relative because he's a little mountain in the area. Yay for him. This guy is called absolute because in this whole graph, the whole thing, he's the very, very highest point you can go. Okay? Absolute, max, and maximum, relative maximum. We also talk about a thing called minimums. Now, I'll be honest, I have sat on the ocean floor, yay me. I went to Monterey, I went down 80 feet, I sat down there, held an octopus, yay. Is 80 feet impressive? It's okay. I mean, it's not bad, 80 feet under the water. That's called a relative minimum. I was under the water, 80 feet down. Not bad, not bad. If you, though, go with James Cameron in his titanium-built sub and go all the way down to the bottom of the abyss, that is the absolute minimum, and that is impressive, right? Okay, now I have a trick for you guys, and I'm going to need you to talk to each other real quick. I need you to look at this graph. Everyone's looking. I have a spot right here. I need everyone to look at this. I need you to talk to your neighbors, and I need you to give that guy a name. Is he a maximum? Is he a minimum? Is he absolute? Is he relative? That spot right here. Talk now. I'm going to call on someone to tell me what it is. Talk to each other. Decide what it is. Girls, decide that spot. Hi, decide that spot. What did he say? He says relative. No. Okay. Kai tells me it's a minimum. Do we agree with Kai? Yeah? Kai also says it's a relative minimum. Is it relative or is it absolute? Is there anything on this graph that's lower than that point? Yeah. There are. These guys, they're going all the way to hell. They're just going to keep on going to the middle of the earth, right? Yeah, they're lower. So this guy is a minimum, but he's only a relative minimum. Look at this guy. It looks like this guy is a maximum. He is a maximum, but these arrows are higher. So he is a relative minimum. Maximum. Relative maximum. So there's one last thing to learn, and then I'm going to shut up, and we're going to try 2 examples, and then you're going to work on your homework, and it's going to be easy. The last critical point that we want to talk about are roots. And you guys already know this, so write this down. It is where your graph crosses the x-axis. Those are called the roots. That matters in the next chapter. That's where we get our answers from, right? So if we have a graph, it used to be when we had U graphs, we get 2 answers, right? One right here, one right here. But we're going to be doing fancy graphs, and we're going to look like this. We're going to have something that looks like this, and we're going to have maybe have more roots. The roots are right here. That's a root, that's a root, that's a root, that's a root. And how we would write that is like -5, 0, -1, 0, a +2, 0, and let's make that 6, 0. Those are the roots. They are a very important critical point because that, in the next chapter, is where we find our answers. So when we're solving these bad boys and you have Desmos, you can just get your answer right off of the graph and you know where it crosses the x-axis. Does that make sense? So here's what we're going to do. Really light work. So I would say, as many of you who have them, get out a Chromebook. If you don't have one and you want to borrow one from me, you can. Or if you want to share with a neighbor, that's cool too. We're doing 2 examples in the night. Shut up. If you would be so kind, my sweet, sweet potatoes. And go to Desmos. Everyone's got, and again, I have like three more computers if you need them. Are we good? So here's my suggestion. Gentlemen, guys, take these. I'm going to do 2 examples. My advice is what I want you to do on the bottom of your notes. We're going to put a graph in Desmos. You're going to make a goofy sketch on your paper. It doesn't have to be perfect, but then you're going to write down what I'm going to tell you to write down. Are you ready? So the first thing I want you to do, if you would be so kind, is in Desmos, please put in this dude right here. Put that guy into Desmos. Now, I'll be honest with you, I am the queen of lazy, and I don't use the exponents. When I type this into Desmos, I am literally going to go 2xx minus 16x plus 27. It's that easy. Okay, here comes the hard part. You ready? Oh, it's so hard. You are going to label, you're going to list all of the important critical points. And guess what? If you touch the graph, Desmos gives them to you. That's why we love Desmos. So the first thing I want you to write on your paper is a little sketch of this. Like, and I mean like a goofy baby one. I mean something like this. Like you literally get a, oh, let's see, I'll do it over here. I mean, like genuinely do something like this. Go la, la, la. Like literally just do that on your paper, right? That's all you have to do. But what I want you to do now is let's find all of the points that are important. So here we go. Let's do it. Oh, do I want to say that? No. So the first thing is write the word roots on your paper. And let's find the roots. And here's how much work you have to do, you lazy, lazy toads. What the hell? Oh my God, I have money. Now, here's my deal. Am I going to write that whole number down? Dear Lord, no. I am going to round. I don't care where you round to, as long as you round correctly. So listen carefully. I would put 2.4, comma 0. That's what I would put. I had other kids who said, Miss T, I like using 2 decimal points because that's how Mr. Sarisa made me do it last year. That's excellent. But listen, 2.41 is not the right answer. It's 2.42. So if you're going to round, my lambs, round right. That's all I'm saying, right? If you're going to round correctly. I don't care where you round, just don't round badly. Are we cool with that? How about this one? Am I going to make it 5.5? No, I'm going to go 5.6 because I am not an idiot and I know how to round. Okay, those are the roots. We're not done yet. Love that. Love that. Next critical point right there, 4, -5. But we have to say what kind it is. And we can't just write critical point. We have to say what it is. It is an absolute minimum. So you're going to say 4, -5, absolute minimum. And that's what we're doing tonight. I know. So I'm going to have you practice one more, and then I'm shutting up. Okay. You ready? Okay. The next one I want you to put into Desmos is, I don't like that one. Let's do this guy. This guy right here. There he is. Do that guy into Desmos. There he is. Hey, you know what I would do? I do 4 to the fourth or x to the fourth? No, I go x, 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 x. Like I just put in 4 x's. Because I'm lazy. I mean, you can do exponents if you want. I just don't. Don't forget that negative. Negative. Watch it. 1, 2, 3, 4. 4, 1, 2 minus 6. Okay, let's take a look at him. Could you use a graphing calculator for this? You can, but man, just look, the points are all already there for me. I don't even have to do any work. Let's start with our roots. There are 2 roots up there. Here's one, and here's the other one. So you would make a little sketch on your paper, nothing hard. You're going to write the word roots. You're going to write this guy and this guy. Would I put this whole thing? No. Would I make it negative 0.8? I would. You want to go negative 0.84? You can. Talk to me. Because it's x. The problem was the original one looked like this. X to the 4th. You with me? You cool? Okay. Let's find some other important points here. Looks like we have something there. Am I going to write that whole thing? No. I'm going to write negative 1.5, comma, 2.9. That's what I would do. But the important part is to tell me what is his name. Absolute maximum. Absolute maximum. Be careful. I was in such a rush today when I did your answer key. I was like, oh, here's the other one. And that was a relative maximum. And I was like, I'm done. But I missed this dude right here. Looks like we've got a relative maximum and a relative minimum. So make sure you're getting them all. And if you're like, Miss T, really? Is that all there is to today? That's all there is to today. Nice start. Okay, for my tape people who heard me yell at everyone today, goodbye, yes? What? Oh, the roots are right here. What? And it was super great doing class with you today. Goodbye. Is that my outro? Am I singing? Okay. No, I can't. I got that. Okay, got that.